Thank you. Appreciate that. Thank you. I'm Brian Green, co-founder with Tracy, and I also want to welcome you to day 4 of the 2016 World Science Festival. The program tonight on gravitational waves. It's a timely program. I trust you all heard the announcement on February 11th, or you read about it. The first direct detection of gravitational waves. Amazing, amazing discovery. And we have here tonight a group of the very individuals who made this discovery possible. I'm going to bring them out in just a little bit, but just a few words at the outset. You know, this discovery, just to put it in context, it's the kind of achievement that happens maybe a few times a century in fundamental science. I mean, we were thrilled some years ago for the discovery of the Higgs boson, something that was searched for a very long period of time and finally was definitively discovered at CERN. Great discovery. This ranks on par with that kind of experimental observational achievement. And the other side of the story that will come out in the conversation here tonight is that whereas for the Higgs boson, just about everybody was convinced that the experiments would succeed. I mean, most people who were following closely the search for the Higgs boson were saying, well, if it's not found, that's the craziness. I mean, this has got to work out. The theory says it. All of these circumstantial evidence suggests that the particle is out there, and indeed it was found. Now, with gravitational waves, as we'll see, there was never really any doubt after, I don't know, call it 1950, 1960, that these ripples in the fabric of space were a real feature of Einstein's general theory of relativity. But there definitely was controversy as to whether we would ever have the capacity to catch one of these waves. And we'll hear about.
Huh? Did I hear Brian Green correctly? Did he say that we were always expecting to find gravitational waves after, say, 1950? Well, Brian Green, I don't believe you ever mentioned that before the LIGO announcement. And I'm going to show you Brian Green on the 100th anniversary of Einstein's theory of relativity, explaining how gravity is simply the curvature of the gravitational field, or the warping of space-time. And curiously, he doesn't mention any rippling effect when he's explaining it to his children and the public. Let's take a listen.
To explain the essential ideas. So, Einstein wants to know how the force of gravity works, how the sun communicates the pull of gravity across empty space to the Earth. Here's the idea he comes up with. He says that the fabric of space is nice and flat if there's nothing there, no stars, no planets, which would mean that if an object rolls through that environment, say this is a comet or a planet, it will go in a nice straight line trajectory. But the key thing is Einstein says that if we have a heavy, massive object like the sun, Einstein says that the sun, merely by being within the fabric of space, causes the fabric to curve, to warp. And then other objects, like the planets, the Earth, Mars, and so forth, he says they go into orbit because they're rolling along the curved environment that the sun creates. This, according to Einstein, is how gravity is communicated from the sun to the Earth, to Mars, the other planets. This is how gravity works. Now, we did a little version of this demonstration not too long ago on the Late Show with Stephen Colbert. We got a lot of really great response, and a number of great questions were asked online. So let's answer the 2 most frequent questions that people ask. Okay, question number 1, Alec.
Why isn't the Earth spiraling into the sun?
Yeah, exactly, right? When you look at the marbles, they're all spiraling into our yellow shot put here. So would that happen to the Earth? Why does the Earth spiral into the sun? Well, the answer is these marbles are spiraling in because they're losing energy, because of their frictional interaction with the spandex. In empty space, there's virtually no friction at all, so planets hardly lose any energy. Now, they actually do lose a little bit because the planets can cause the fabric of space to ripple a little bit. We call it gravitational radiation. So if you were to wait about 10 to the 20 years, 100 billion years, if the Earth is still here, it will, in fact, spiral into the sun. Very good. Second question, Sophia.
Isn't it gravity that pulls the yellow thing down?
Yeah, right? So if you think about it, the reason why our yellow shot-put sun is causing the spandex to warp is because gravity is pulling on the shot-put, right? So we're kind of using gravity to explain gravity. But the key idea is that Einstein says that the sun, merely by virtue of being in space, causes the fabric of space to warp. That's the key idea at the heart of the general theory of relativity.
Did I hear right again? Did Brian Greene admit a flaw in the theory of general relativity? I believe he just mentioned the premise of circular reasoning that we expect all freshman college students to know on their LSAT. So what is circular reasoning? If you spot an argument where the conclusion is synonymous with the one of the premise and no evidence has been given to show that the premise is corrective, you've got a circular argument. And we just heard Brian Greene say, well, yeah, that's people do point out that we're trying to explain gravity with the argument of gravity. And then he brushes right over it. But the main theory is the sun pulls down the fabric of space-time, and that's why there's gravity. Okay. That's something we expect a freshman graduate to point out as circular logic.
A certain kind of internal fortitude. It takes a certain kind of vision. It takes a certain kind of stubbornness. It takes a certain kind of independence of spirit to devote your life to this kind of project. And our hats are off to the individuals, they now number roughly 1,000, who made this discovery possible.
Yes, it does take a certain amount of determination, vision, and creativity to go against the conventional wisdom of the age. And I believe that is found in Immanuel Velikovsky.
Recent discoveries in space have amazed and perplexed astronomers. Current popular theories in the sciences can neither predict nor explain the phenomena we are now observing. A new theory is being proposed. A theory which can both predict and explain the data coming back from deep space. Its implications are profound and affect all the scientific disciplines. It is in fact a synthesis of the disciplines, a synthesis which has already led to discoveries that link modern astronomy, leading-edge plasma physics, and ancient mythology. The electric model offers us a new interpretation of the workings of the universe, the history of our solar system, and even human history.
So later on in this clip of Brian Greene explaining his work, The Elegant Universe, he talks about the fact that Einstein revolutionized Newton's theory of gravity. And basically what Einstein introduced is that space, time, or the universe has 4 dimensions. 3 dimensions of direction, and the 4th dimension called space-time. And it was the fact that it was across this flat surface of space-time, or the fabric-like surface. It was like a trampoline, and this unified fabric is warped and stretched by heavy objects like planets. And it's the warping and stretching that makes us feel gravity, but gravity really doesn't have a force. It's just our acceleration downward. And again, I knew something was wrong in 2008 when I saw this. And I knew that you'd have to explain why we accelerated downwards toward a heavy object and not upwards. I mean, it could be a mirrored universe and we would be accelerating upward. What is the difference? Well, there are other forces of nature interacting on the 2 bodies as they come in close proximity of itself, which is very Newtonian. But these brilliant scientists after Einstein decided to throw out all Newtonian physics, which is throwing out the truth or the baby with the bathwater, and invent something completely different that ignored all the grand minds before it. Well, I'm also here to tell you that Einstein was the only one of his era that believed that gravity was not a force. And I don't know who convinced the rest of the students after him that gravity was not a force, but someone did, because in 1920 he came out with a definitive paper, I'm talking about Einstein, simply saying there was no force of gravity, it was only the warping of space-time, which again is nonsensical, because what is space-time other than a gravitational field, and it's electromagnetic. We all know that, except for those, like I said in the previous video, who are being paid not to know, or those who are so closed-minded and rigid in their thinking they refuse to accept any new evidence. I was also late to the debate, which is right now, in the fact that there are many people that have historically proven that Einstein, as a patent clerk, perhaps plagiarized his entire theory from other more educated and more brilliant particle physicists at the time. And this is a Wikipedia entry that discusses this debate. But what I notice in Brian Greene's introduction about the fact that Einstein at first thought there were gravity waves, but then, he made a mistake, and then he decided there weren't any gravity waves. And then everybody after him just interpreted the way that Einstein said, is that there's no gravity waves. That leads me to believe that perhaps this debate over Einstein just plagiarizing his theories might have some substance, because that mistake, quote unquote, by Einstein, to me, doesn't prove it was a mistake. It's more rational to believe that maybe Einstein also may have purloined that initial paper that mentioned there were gravity waves, and then later on said no, there were no gravity waves, because Einstein really didn't understand his own theory. If he, in fact, he was just kind of copying other people's work, then he had no real understanding of his own theory of general relativity, because he changed his mind over gravity waves. And I am going to show you how all the physicists at the time of Einstein definitely believed that gravity was an electromagnetic field, and that indeed there were gravity waves that traveled over the field. So let's start with the Wikipedia article on the debate of whether Einstein purloined or copied his ideas from other physicists. And we're going to start with special relativity. And this, it states, in 1900, Poincaré published a paper in which he said the radiation could be considered as a fictitious fluid with an equivalent mass of mR equals E over C squared. Well, I do believe that's the special relativity equation that is attributed to Einstein, but it looks like Poincaré developed that equation before Einstein. Also, other scientists have pointed out that this equation of E equals mc squared was also known by Newton 300 years before Poincaré and Einstein. Also, Descartes knew that mass was energy, and his equation, which was wrong, his equation was energy equals C, or energy equals light. He failed to just add the geometric calculation of squared above it. But since Descartes, people were knowing that mass equals energy and particles equal energy, and they're all part of the same field of electromagnetic. They just have different manifestations. And here's the Lorentz paper containing the transformations in his name in 1904. Now, Lorentz developed the transformations of the energy exchange between the particles, and how they stretch and they expand and they contract and they expand, because a particle can only accept a certain amount of energy, and it's either got to expel that energy or into another particle, or it has to reduce its energy by going to a lower state, or if it doesn't do any of these things, it's going to burst. And particles don't like to explode, nor do people like to explode, because the force of gravity, as we know, if we hit the Earth, there's a definite force, and it's called the explosion of the human body against a greater mass called Earth. And hey, that's demonstration enough for me of the force of gravity. It's not an acceleration with no force. It's an acceleration caused by a force. And that has been the debate between these warring factions since Einstein's grand mistake called the theory of relativity, in which everybody believes that relativity is equal, or gravity is equal to acceleration. They call it the equivalence theory. Ho-ho. Okay, we'll move on. Here's Wikipedia identifying the general relativity debate, in which David Hilbert is attributed as actually writing the field equations for the relativity theory. And Einstein, who published his paper 5 days before Hilbert's, is now noted to have developed it, even though Hilbert was attributed to developing the actual equations. So this has been a very important conflict between who actually discovered these field equations. And again, nobody in history knows about Hilbert, but at the time they called them the Einstein-Hilbert equations, because Hilbert and Einstein traded information and actually did lectures together. But let's go down here to general relativity, where we talk about before 1997, the commonly accepted view was that David Hilbert completed the general theory of relativity at least 5 days before Einstein submitted his conclusive paper on this theory on November 25th, 1915. It goes on to say, for some reason, some powers that be held up Hilbert's article and wouldn't publish it until after Einstein's, citing that he needed to rewrite things. And that's kind of a famous way of jumping the gun and on somebody who's discovered something before you. What you do is you basically hold up their publication until you can quickly publish your own. So then we had the history and theories of ether and electricity in 1915. And of course we know that with Einstein's general relativity, he threw out the ether theory, or the fact that there's actually a fabric. Okay, what is a fabric? It could be called an ether, or a gas, or electrical energy fabric, which is, it's just that these scientists after Einstein make no sense at all. They've completely thrown away thousands of years of scientific data in inventing their new theory of the vacuum, a new theory of gravity equaling acceleration, which makes no sense at all. But anyway, here's Lorentz, who's noted in developing the stretching and pulling of electrodynamics and the equations that formulated them. They're called the Lorentz transformations, and they're based on electromagnetic accelerations and electromagnetic contractions, etc. So it was all here, all the information for these new Brian Greene gravity foe experts to know that basically gravity is an electromagnetic force. So we can go down here and let's see what else I've got. Oh, did Einstein develop the field equations independently? We've already explained that. No, everybody believes Hilbert did. And then special relativity, again, is attributed to so many different people before Einstein. And basically, Einstein decided in 1920 that there was no gravity waves. So that initial paper Brian Greene refers to, that Einstein made a mistake, to me, it suggests, and it's reasonable to conclude, Einstein didn't even understand his own theory. And perhaps he didn't understand his own theory because he was, shall we say, purloining or copying people. And the other theory they've got about Einstein is that his wife actually came up with equations and that she was the mathematician in the family. And it could be logical to conclude that Einstein would see all these papers and bring them to his wife, and she's the one that was helping Einstein write his theory of general relativity. And the reason why I'm kind of talking about this is not my debate. This is a debate of many others. I kind of ignored it until this new discovery by LIGO of the gravitational field. And the reason why I am now bringing this up is it's making sense to me that nobody understood Einstein's theory because Einstein himself didn't understand it. And I actually went to Einstein's work on general relativity and I read it, and I didn't come up with any of this stuff that these Brian Greene comes up with. Einstein, in his paper, if you read it, does not say gravity is equal to acceleration any place in his general theory. And if you interpret it correctly, he is just saying that gravity is a field that can be eliminated because if two other objects are acting in relationship to each other in the same gravitational field, which is the universe, you don't need to worry about gravity because gravity is the constant, and on either side of the equations, you just mark it out, and then you can do the algebra between the two moving bodies within the gravitational field. That's all general relativity says. Here's another article out of The Guardian. Einstein's E equals mc squared. Was it an Italian idea? And yes, it was. It's not only an Italian idea. It was a Newtonian idea 300 years before. It was a Descartes idea 500 years ago. But let's take a look here. It says that Olinto de Preto, an industrialist from Vicente, published the equation E equals mc squared in a scientific magazine in 1903. And Umberto Bertolucci, a mathematical historian, has said that. And Einstein allegedly used de Preto's insight in the major paper published in 1905, okay? But de Preto was never acclaimed, said Professor Bertolucci. And that's what Lorenz and Poincaré and Hilbert's main objection to Einstein is he gave no references to their work in his publishing his own paper. So his ideas were not new and they were not novel. They were, shall we say, cited or referenced by Einstein without giving any attribution to the actual people that came up with the ideas. And this again leads me to believe that Einstein didn't even understand his own theory. And we have demonstrations by teachers like this.
Warp space-time, and objects are not feeling a force of gravity, they're just following the natural curvature. And so
Did you hear that?
Sheet of lycra. Where do you get this?
Objects are not feeling a force of gravity, just the natural curvature.
There's literally a spandex.com. You can get a
I would
sheet like
disagree
this
with
to buy
that,
the
and
same
so would an
stuff.
egg. If you dropped an egg from a second-story window and it hits a larger mass called the terra firma or the Earth,
So you put matter,
it
and
certainly
works
feels a force of
so if we have
gravity
another
as
object,
it
it also
explodes
works
all over
space-time.
the place
They
in,
feel that,
shall
and
we
they're attracted
say,
to each other.
an omelet.
And so that's Einstein's picture of gravity. Objects warp space-time, feel that curvature, and move accordingly. And if you have more mass, right there.
Look at all those sweet
If you
little
have more mass,
students
it's going to
completely believing
bend
what he's
space-time
saying.
more. And so if you have objects there, they are going to respond to that, right? And so you put something there, now it's attracted.
Oh,
Now, in reality, that big mass would feel the warping of space-time by the marble too, right? And it would move a little bit, but we usually ignore that. You know, the Earth makes the sun move a little bit, but it's so small you can ignore it.
now mind you, I'm not making fun of this particular teacher. This particular teacher is simply repeating what his textbook requires him to tell the students of the nature of gravity. But this next section is, I must say, somewhat hilarious. Listen to his explanation of why the planets travel the same direction.
All the planets are going around the sun the same way. Why is that? Did God decide that he only liked clockwise, or depends on whether he's above or below the solar system, right? Why is everything going in the same direction? Well, the answer is it wasn't. Different directions. But there was a preferred direction. This it formed from had a slight preference one way versus another, and things going the opposite way got eliminated.
Oh my goodness. That's a very scientific explanation. Not.
That works 90% of the time.
There's a preferred direction in the universe. A preferred. And so all the others were eliminated. Well, I think Uranus and Venus kind of counteract that, because Venus is spinning in the opposite direction of Earth, and Uranus is spinning in a perpendicular way to the Earth. So spins certainly don't follow this preferred God direction.
The ones going the
Here's another genius repeating the same nonsense.
Force accelerates it toward the ground. But what if it's really the ground accelerating up to meet the apple?
Yeah, that's it. The ground moves, not us.
Suppose I drop an apple. According to Isaac Newton, the ground can be considered at rest. Earth applies a gravitational force to the apple, and that force causes the apple to accelerate downward. But according to Einstein, there's no such thing as a gravitational force. Instead, it's more appropriate to think of the apple as stationary, and the ground, along with everything on the ground, as accelerating upward into the apple. Now, what I just said sounds preposterous and maybe even moronic, but it's not sophistry. There's something substantive here. And today, I'm going to clarify what exactly this point of view means, why Einstein came to adopt it, and how it planted the seeds for what would eventually become general relativity. You ready?
So in 2008, after reading source material of Einstein, source material of Newton's Principia, source material of some of Einstein's colleagues, Niels Bohr, one of the persons I really did understand, and I will discuss him later, is Max von Laue, who completely clarifies the field theory of general relativity. And he corrects all the misperceptions that we are now hearing in science, and the belief that there were, for I guess since 1950, no gravitational waves, when everybody during Einstein's time period definitely said there are gravitational waves over the flat field of gravity, and that's how all the forces interact. So you have a field of gravity, which is the universe, and then the forces are carried in the waves. So this was my attempt, and here was, I thought, a very good attempt, seeing that I only have high school geometry. But the unified field principle is this. All energy states and force states are electromagnetic in origin and are limited to multiples of speed, c, which is the speed of light, which is 6.67 times 10 to the 34th. And then all force states, see, you've got energy states or radiant states or resting states. That's the speed of light, and that's the resting state of c. But all force states are limited to multiples of h, or Planck's constant, of 6.67 times 10 to the 34th. You see how the speed of light is identical to Planck's constant? Well, you wouldn't know that now if you look in Wikipedia, because they've mixed all these numbers up, and it's my belief, based on reason and based on history, that they mix these numbers up every so often just to throw people off the track. But you can see Planck's constant was the same as the speed of light in Wikipedia. I think I got this from Wikipedia or something else during 2008. So then I go down, and the rate of h is the rate of flux, or the force. So you've got a quantum state of a photon at c traveling through c, but as it picks up energy, as it picks up speed, it's got to emit that energy in order to maintain its constant rate, or shall we say its own structure. It doesn't want to explode either into nothing. So a particle of light, or a photon, or a particle of matter such as an electron will expel its energy, excess energy, at the rate of h. So that produces a flux or a retraction or a force on everything that's surrounding that little electron. It's sort of like a choo-choo train going up the hill. I think I can, I think I can. Well, it's choo, 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 choo. So it picks up force, acceleration, but it's got to release that excess energy in the choo. So you got choo, 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 choo. You got energy expelling of the energy, and that's called retraction, absorption, and emission. Absorption and emission. An electron can only absorb 4/3 of its weight in energy before it needs to expel it in a photon or another electron that it combines to. So it can share that shared energy. That's called conservation of energy, and this is a Newtonian principle from the Principia. So again, my belief that Einstein, I'm coming to this belief. I always held Einstein in complete awe. That is why I read his seminal work, and whatever Brian Greene Collective is saying is not what Einstein said in his paper on the theory of general relativity. But I'm going to show you something else that I do believe is very interesting, seeing that LIGO now thinks they've discovered something groundbreaking, and Mr. Brian Greene is rewriting his own history. I'm going to go through and find all the areas in this paper that I wrote in 2008. Now remember, it's 10 years later, and they're now making big announcements about gravity waves. So here we are at the beginning of my paper, and I'm going to search for all waves. So let's start. Here's wave. Crossing electromagnetic energy, waves create the superpositions and velocities of C6. And in here, I'm talking about the short-sided lattice, the negative background of gravity, and the universal field of the universe. Energy collapse under pressure into particles, defined as the anyway, wave. Let's find another wave mention. Here's another wave mention. Let's move this aside. I don't know if I can. Sound waves that oscillate and vibrate in the lattice energy of, I will tell you what the Schwarzschild metric is, etc., etc., etc. But let's go on down. Oh, here I say these energy states alternate between resting and the quantum energy, which is E equals mc squared. The quantum energy state is 4/3 mc squared, and the resting state is mc squared. So let's go. And so it's the angular momentum that determines how much energy a particle can absorb before it needs to emit and produce the force or flux of the particle. And this was all in the papers I read. There was nothing new here. It was all done, and which is kind of aggravating to me now that they're still pointing to Einstein as being just mistaken when he dismissed that gravity had any force. So let's find it again. Oh, here's another vibrating wave. At some point, the flat, linear, spiraling magnetic electric field, I'm saying, waves could not hold their centers, splitting them into further smaller waves and flowing out like a lattice. This is just my theory here, but I base this theory, see waves, 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 waves. Let's go down here. We can go down, 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 down. And I mean, it just, here's the binary supernova, black hole formations creating huge energy pulses, producing the Maxwell advanced and retarded waves. This is the energy of the universe. All right, this is what I'm explaining. And I'm explaining it in terms of when a supernova that we see in space explodes, it's going to explode huge waves across the universe. And what's also going to happen with that supernova as waves go crossing at avalanche forces across the universe, it's also going to have a retraction, and that's going to be pulling energy from the other side of the universe. And this universe continues in this wave interactions that are magnificent. It's called the interaction of huge unseen waves because we can't see them, because by the way, space has a negative charge electron shelf around itself that we can't see through. It's kind of like a skin or a brain or a membrane. We can't see what's happening underneath gravity because it's dark. It's dark because that's the magnetic shelf or the valence shelf of the universe itself. So let's just, and this is just extrapolating from the fact of particle physics. If we know what an atom or an electron is doing, we know how everything else made up of atoms and electrons are going to act. They're going to act in these self-consistent principles. They're going to be waves. There's going to be particles. It's going to be depending on how they, anyway, it goes on down. I don't think we need to go further. I'll post the paper. It's been posted forever. Of course, it's not a perfect paper, but it was a start in 2008, and other things got in my way for going through this. But I will tell you, I did send it to Brian Green, of all people, who I didn't hear back from. But I did hear back from several people that I thought was interesting. And I'll post their replies to me. One of them was the Electric Universe people. I sent it to them, and they responded in a very kind letter, and I will post that. And then the other one was Milo Wolf, who was a student of Schrodinger, and he basically had a theory that atoms and photons are not particles in the plain sense. They're waves, and it's the interaction of the waves that produce those momentary sparks of particles in their intricate patterns. And Milo Wolf responded, and we exchanged very nice email to each other. And but these poor wave theorists under Schrodinger, which Schrodinger championed, have gotten short shrift because for some reason Einstein and his big blunder have been repeated over and over again, and I believe has put back obviously Newton's theory of gravity by 300 years, and then you can go all the way back to the ancients. This has been the worst blunder of the modern century. We've spent over 100 years teaching students the wrong idea of gravity. While Milo Wolf and I were exchanging emails, he was kind enough to share some of his papers with me. Milo Wolf had developed his theory, which he called the WSM, or the wave structure of matter. And here he begins his abstract as the great philosophers of cosmology, Clifford, Mach, Einstein, Weil, Dirac, Schrodinger, he studied under Schrodinger, have pointed out that only a wave structure of matter, particles, can conform to experimental data and fulfill the logic of reality and cosmology. And they prove this through cymatics, through water structures, through crystalline structures of snowflakes. That whole science of cymatics is really interesting, where matter and not only matter, but water conforms to frequency waves. Sand conforms to frequency waves, and it reveals the underlying structure, which is in a wave pattern. So that's kind of a given at this point, but nobody seems to be giving anybody, shall we say, any respect for the fact that this has always been known. So here we've got my whole paper, not paper, but it's a breakdown of Milo Wolf's wave structure theory and my theory of black hole model, which basically uses, you can see Max Abraham, 1875. That's the electron has 4/3 C2. That was his equation that states that the particle of matter can only absorb 4/3 of its mass, and then it will either explode, emit a photon, and go down to a lower state to keep its state constant. And then, let's see, quantum fields of space-time. We've got flux, which is the energetic force, and 4/3 the resting mass. So gravity, I posited also had a resting mass, which is, I posited it as C quadratic, because I just said it made sense that C of light, of the electromagnetic light, and C squared of matter together should equal the gravitational force, so I put that at C3. I don't know if that's true, but I did use their terminology, quantum vacuum density. The rate of flux is 1/2 of HW. Here's the Casimir energy, which also points to the fact that this energy state of flux has this point of energy, and it's quadratic for pi is four planes of pi. So then, anyway, this was my attempt just by reading source material. I'm sure other people can come up with other things, but this has been published, so it's not like it's anything new. I've got a website called the Fine Light Opera. I go through Dirac. I read Schwarzschild. Here's, these physicists need to start actually reading source works. Here is a Schwarzschild metric, and basically it's white hole, black hole, and then Kruskal determines that the white hole, black hole configuration is in a lattice effect on a flat dimensional plane. So if you want to extrapolate to that, that means that the Earth is encased in a white hole, encased outside by a black hole, or the electron shelf is what we see in space. Here was the paper, or the website, that I put up right after I published my paper on the internet, and it's still there, though it's been up and down depending on different time periods in the last 10 years. I think I haven't touched this in probably going on 6 years. But here's my paper, Fine Light Opera Research Looking Toward a New Paradigm. And then I put the electro-strong forces are symmetry breaking under the pressure of C8. I've got a paper there, the black hole universe. And again, I'm the one that, in this paper in 2008, I identified the exploding supernovas and exploding outward and inward pressure causing huge tidal waves across gravity. And then down here I mentioned that we don't need extra dimensions to understand it, that there's only 3 states. One is a resting state, one is quantum state, and then the trans-Planckian space-time is that space-time we cannot measure with our measuring instruments, so we have to extrapolate. But I say all particles in the universe have less than infinite angular momentum, and so only temporarily torque the vacuum density field, which is the gravity field, before sliding back to zero state energy of the vacuum. Particles are simply temporary light energy that torques the fabric, etc. But that is what a gravity wave is. It's torquing the field without releasing any light or any emissions. It's actually reaching at maximum torque, tensile strength, and then sliding across the universe. And that is what LIGO is maybe detecting. I don't know, but certainly I'm going to go to Wikipedia and show you how much they've spent on this LIGO experiment. So here we are at Wikipedia talking about the LIGO, and I just think this is so interesting. It goes through and says that there were a few scientists that were working on this LIGO experiment, but it only gained strength, I think, in about 2010 is when they started really going after it. And of course, I predicted the gravitational waves in my 2008 paper, and that wasn't difficult, by the way, because that's what the original quantum physicists were saying. Einstein was just misinterpreted, or Einstein didn't understand what he was actually extracting or plagiarizing, as they say. That's a harsh word, but that's what some people believe. I don't know. I just jump right now into that debate because it does seem that everything that follows Einstein is following this huge mistake of gravity not having a force, which is like completely boggles my mind. But I've only got let's see, high school geometry behind me, but I do, like I said in my previous videos, I can read and I can comprehend what I read. And it's not that difficult if anybody actually took the time to go back to the source material. But let's go forward here. The LIGO, the world's largest gravitational wave facility, completed a 5-year, $200 million overhaul, a total cost of $620 million to detect a gravitational field. Did you get that? 620 million? And then they say they've got 1,000 people on staff and they just barely detected it. Let's see, 2017, 100 years after Einstein published his paper that clearly indicated there were gravitational fields, but somehow everybody got mixed up. For 100 years, they forgot Newton, the brainiac of the whole pack. So let's go back, and I just want to note that I love the flat earthers because the flat earthers are ingenious and they are creative. And guess what? While LIGO spent $620 million, I'm going to show you how these flat earthers discovered the same gravitational waves and probably spent maybe $10,000, $20,000 at most. Let's go on. So let's go to FE Astronomy. Steve Torrance, Mike Kavanagh, and Dr. Zach did their experiment where they tracked the sun on a daily basis for 360 days, a full year, and fed it into a crunching machine, and then they were able to determine, we shall see, motion, and looks like gravitational waves to me, just using the photon. There it goes. Whoa! Hey, I'd say that's the force of gravity working in our own atmosphere on those little fundamental particles called the photon. Look at those gravity waves. Woo! And this probably cost them about $10,000 versus $612 million. And how many years? This took 1 year. That's why the inventiveness of us, the common lay people, is, I think, genius. Pure genius. Look at that. Those are electromagnetic fields. And look at the motion there. That's being pushed by nothing more than gravitational waves. And there's the Nazca line, or the spidering effect. And now we're going to look at Joshua's trumpet, or Gabriel's trumpet, blowing apart our worlds, which is next. What I'm going to discuss is Velikovsky. And here's my email to Brian Green. Let's pull this down so you can see. I sent it to Brian Green at Phys Columbia Age.edu. It's Saturday, March 28, 2009 at 3:36. And the subject I put, attorney who admires your work and believes in black hole universe. And so I introduce myself here, and then I give him my abstract. And as we come down, I talk about Schwarzschild black holes and a new paradigm, starting with, if there is anything at all, it must be light. All forces in the universe are electromagnetic in origin. They are differentiated only in their total energy content, limited to multiples of C, and interactions limited to multiples of H. Light is C, matter is C2, and gravity defined as a total energy content of the universe at C quadratic. Simple. There's alternate states resting in quantum energy, or that's called the mass energy, which, as we know, the electron is mc squared, and as I further elucidate, the quantum physics at the time of Einstein indicated that the electron, which is c squared, could only absorb the atomic quantum energy level of 430 of C2, or it would explode, and that is its speed limit. Cannot go faster, and it actually does not go in any direction. It's a packet of energy. It's called a standing wave, in which it swirls in and out at a constant rate, which creates they call it a standing wave or radiant energy particle. And if it has energy mass of greater than 4/3 C2, it explodes and loses its structure. That is why we cannot travel faster than 4/3 of C2, because we would explode. We are limited to multiples of C, and we can only travel only 1/3 or 25% of the speed of light, or our atoms will explode. So anyway, that shows that. And here's my message to Walt Thornhill at info@holoscience, and mine is CJ Smith at Sophia551. And this was the website confirmation. I said, I am an attorney. 14 months ago, I had an insight into the universe being electromagnetic, with electric currents producing rotating magnetic fields that spin the universe. In order to produce the steady state system of the dynamic universe, the universe must emerge from a black hole. And he sent back a very nice letter saying, thanks, CJ, keep up the exploring. But he also sent me his recent paper at that time, which we've got March 23rd, 2009 again. I'm just about to post a news item that shows that once and for all that black holes are impossible. Not only that, I've shown what is at the center of galaxies is the electric galaxy. Okay, so what he's saying is, hey, I don't believe your black hole theory, and by the way, just keep on exploring. But I thought this was very nice, so I did click on his electric galaxy paper, and here it is. Now, of course, at the time, I was into reading the source materials on particle physics, so I really kind of didn't know what he was talking about. And likewise, when I said something was a black hole, he didn't know what I was talking about. And what I was talking about was not a black hole as a black hole. I was talking about the spinning rotation between the electric and the magnetic forces, and how they begin at the event horizon of a short child imaginary black hole, which is 3,000 meters across, and it is in this gravity well that all photons collect, and they produce the spiraling effect of the photon torsion field. I now know that's what I was talking about. He does not know what I was talking about, but I think we were talking about the same things. I believe definitely in his theory that the forces in nature are all electromagnetic. They obey Faraday's, they obey Maxwell's equations, but particle physics uses its own terminology, and unless you know each other's terminology, you're not speaking the same language. And so that brings me to a biblical reference, which is the Tower of Babel, and how it says that the Lord destroyed Sodom and Gomorrah because they attempted to reach him through building a tower to the heavens. And how he destroyed them was he vexed them or cursed them with not understanding each other's languages. And so they were unable to communicate. And that's the mythology of the sciences right now. It's the Tower of Babel, where the languages are so different, but they're meaning the same things, but no one's listening or trying to understand. So that is the end of this video. I know it's long, so I will try and shorten it, but I thought this was interesting, and I truly am in awe of electric galaxy theory. And the reason why this came up again for me was I listened to a program discussing Velikovsky and the electric universe, and so I thought I'd bring this up at the end of this video.